when objects are arranged along a closed curve like a circle or ring, the permutation is known as circular permutation. Every 4 arrangements in circular permutation, for this example, is considered it as 1. But in case of circular permutation, so the places remain same, so therefore it is 5 factorial. Hello everyone, a warm welcome to one and all. So this is your Shruti ma'am, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence, Mysore. So welcome to the 5th session of permutations and combinations. So in the last class, we have learned in details about the permutations and also the arrangement of numbers, letters, as well as arrangement of books. So in session 4, we have learned about the arrangement of letters when repetition occurs and when repetition do not occurs. Okay, so what happens when repetition occurs, when repetition do not occurs? So when you have different letters, like for example, Monday, so there will be 6 letters in 6 different places. So the arrangement of 6 different letters can be taken as 6 factorial. Okay, suppose that is what the first point, when the repetition, so when the repetition do not occur. When the repetition do not occur. Suppose you have many letters repeated, then what happens? For example, I'll take hopper. So what is the permutation of these letters? The permutation of these letters is also 6 factorial, but letter P is repeated 2 times. Therefore, you have to divide it by 2 factorial. This is how when repetition occurs in terms of words. So when arranging the alphabets to form a words, different words with or without meaning. So when letters are different, when there are n letters, we can directly write it as n factorial. But when there are letters repeated, you have to divide the total permutation by each letter, how many times it is repeated. So this is about the previous session we have learned. So in this session, today, we will be dealing with circular permutation. So what do you mean by circular permutation? And we will be learning few important formulas based on circular permutation and simple problems. It is very easy for circular permutation. So we will be learning this in today's session. So what do you mean by circular permutation? So when objects are arranged along a closed curve like a circle or ring, the permutation is known as circular permutation. What about the permutation we have learnt in previous session? They are called as linear permutation. Why it is linear? Because we will make the arrangement through straight line either like this or like this. Okay, so therefore they are called as linear permutation. What is the difference between linear permutation and circular permutation? We will be studying it later. So but now coming to the definition of circular permutation, what do you mean by circular permutation? A permutation where all the objects are arranged in the form of a circle or ring. Okay, we'll take the example. Consider the arrangement of the letters A, B, C, D. First, before going to the circular permutation, let me take how we have arranged in linear permutation. So, we have a letter A, B, C, D. In case of linear permutation, if I change the order of the letters, for example, I'll take B, C, D, A. If I change the order of letters, then it is taken as one arrangement. Again, suppose if I write the same thing, okay? So I'll take A, B, C, D in linear permutation as well as A, B, C, D in circular permutation. What happens? Now this is linear permutation. A, B, C, D. Here I'll write A, B, C, D. Like this. Okay. Then I'll change this, the order here. So I'll take B, C, D, A. So here also B, C, D, A. Okay, if I change the order here, the arrangement is considered it as 1. See, this is the second arrangement. But observe the circular permutation here. So cyclic rotation. So A, B, C, D. You will get, even though if you have changed the order, it is same as A, B, C, D. So in circular permutation, okay, so there are number of arrangement which are considered it as 1. Every 4 arrangements in circular permutation for this example is considered it as 1. I'll take one more arrangement here. So let me take C, D, A, B. So look here, C, D, A, B. So which is same as what? A, B, C, D. So therefore, for any linear permutation, if you have 4 different letters, the arrangement is what? 4 factorial. For linear permutation, it will be 4 factorial. Okay, so what I said, every 4 arrangement in circular permutation is taken as 1 arrangement. So therefore, in circular permutation, what happens here? This factorial is always divided by 4. Okay, if you have n factorial, it is taken as n factorial by 4. So therefore, what is 4 factorial? 4 into 3 into 2 into 1. So that is 4. So when you cancel 4, you are remaining with 3 to 1. So therefore, it can be taken as 3 factorial. Okay, it can be taken as 3 factorial. So in general, if a linear permutation for n different object is n factorial, then in circular permutation, it is always n minus 1 factorial. Okay, suppose you have 7 different peoples to be arranged. Okay, in linear permutation, what happens? It is 7 factorial. So you will be arranging like this, 1, 2, 3, 4, 5, 6, 7. So you have 7 different places for 7 different people. So therefore the linear permutation is here 7 factorial. Whereas when you come across circular permutation, it will be 7 minus 1 factorial, which is 6 factorial. So this is what the difference between linear permutation and circular permutation. In circular permutation, so when you arrange the objects in cyclic order, every 4 permutation is considered it as 1 arrangement. So therefore, the circular permutation is always 1 less than the linear permutation. So therefore, you can see here, I have given the example. So here A, B, C, D. Okay, then here A, B, C, D, here A, B, C, D, here A, B, C, D. Okay, so however you arrange, all the arrangements are same here. So here you should take it as C, this one is as D. So however you arrange, this will be same. Okay, so therefore in circular permutation, they are same. So therefore, I have given the example as previous, it is 3 factorial. Okay, so next one. There is neither beginning nor end in circular permutation. So why? So you have a beginning as well as ending in linear permutation. But you cannot have beginning or an end in case of circular permutation. Okay, so you cannot find out. So you can arrange it either BCDA form or ABCD form or CDBA form, anything like that. So there will be no difference in ending or beginning in case of circular permutation. Therefore, the formula for circular permutation is always n minus 1 factorial. Next one. If clockwise and anti-clockwise orders are not distinguishable, then number of circular permutation is n minus 1 factorial by 2. What do you mean by this? For example, I'll take here, I have taken A, B, C, D. Okay, so, and also A, B, C, D. So you can see here, this is one circular permutation. This is one circular permutation. Okay, suppose A, B, C, D is what? Clockwise direction, and A, B, C, D is anti-clockwise direction. So what happens if I want to swift the 2 person, they have to change the places. That is, B must go to D and D must come to B. A and C are same. So if you want to shift those two persons, so what happens? They'll switch to each other. So B goes to D and D goes to D. Suppose when you take a garland or any necklace. Okay, so I'll take an example of a garland or a necklace. What happens? I'll take an example of necklace where red, blue, green, yellow beads are strung together. Okay, so if I hold a necklace like this, like they have first red, then blue, then green, then yellow, red, blue, green, yellow. Okay, if I change it like this, so if I change it like this, what happens here? So red, blue, yellow, green. This is what happens. If I hold a necklace like this, okay, and when I twist it like this, the arrangement will be same. Okay, I cannot change the color beads there. Okay, so their places remains the same, but arrangement is different. The places will remain same, the arrangement is different. So therefore, here I cannot take it as two different arrangement when it comes in the case of necklace or garlands. Okay, so therefore, the factorial is divided by 2 here. When it comes about the person, okay, when it comes about the person has to change the place here. Therefore, it is considered as one arrangement and this is considered it as another arrangement. But in case of necklace or garlands, when it is already strung, we cannot change the place of them. So, just when you rotate it, they look different, but the arrangement is same. So, therefore, here the factorial is divided by 2. So, this is very necessary in calculating the problems of garlands or necklace. Make sure when you hear a word necklace or garlands in statement problems, your permutation, circular permutation formula will be n-1 factorial divided by 2. Whereas in all other cases, it is just n-1 factorial. Okay, so let me take the first problem here. The number of ways 8 persons can be seated at a round table. So I have to locate 8 persons in circular table. So if person 1 is sitting, either I can start from filling here or in any other places. Okay, so the arrangement in circular places will be always n-1 factorial. So how many persons I have to arrange in the round table here? 8 persons. So therefore here what happens here? This is 8 minus 1 factorial, that is 7 factorial. Okay, so when you have to arrange 8 persons in a round table, then it will be 8 minus 1 factorial, which is 7 factorial. Next question. The number of ways 10 different stones be set to form a necklace. So remember the word necklace here. Okay, so remember the word necklace. As I said, when you hear the word necklace or garlands, when you twist them, the order is not changed. The arrangement is considered it as one arrangement. So therefore, your formula is always n-1 factorial divided by 2. So for this question, we have 10 stones to be strung in the necklace. So therefore, what happens here? It is 10 minus 1 factorial divided by 2, which is 9 factorial divided by 2. So this is my answer for the question in case of necklace. Next question. In how many ways 10 beads of different colors be strung into a necklace and the red, green, yellow beads are always together? So we have 10 beads. Okay, so remember the concept, when any persons or any letters have to be together, tie them as one unit. So here we have red, green and yellow. So red, green, yellow beads are together. So out of 10, 3 beads are together. So remaining how much? We have 7. So now how many units you should consider it as? 8 units. Like simple, you should consider it as 8 beads now. Okay, so now we have red, green and yellow as one unit, other 7 beads as another unit. So totally we have 8 beads now. Okay, so therefore how they can be arranged? So we know the formula, that is n minus 1 divided by 2. N minus 1 factorial divided by 2. In case of what? In case of necklace. So therefore what happens here? The formula for this question is total number of arrangement or total ways will be 8 minus 1 factorial divided by 2. So that is 7 factorial divided by 2. So this is for all. What about the arrangement here? It can be placed either in red, green, yellow or green, yellow, red or yellow, red, green. So like that it can change the order also. So therefore here what happens? 3 different beads are there. So it is, so therefore here total ways for this is 7 factorial divided by 2 into 3 factorial. Okay. So assume we have here 10 different places. Okay. So we have to arrange it like this in this circular form. So here let me take red, green, yellow we have. Okay, so total we have 8 arrangement. So but red, green, yellow can also change their places. So therefore it is 3 factorial. There you should not consider it as 3 minus 2 because the places are 3. Okay, they can change itself there only. So therefore it is 3 factorial. Whereas coming to the whole circle, that will be 8 minus 1 factorial divided by 2, which is 7 factorial by 2. Find the number of ways 6 boys be arranged in a circle if 2 particular boys are always together. Again here also 2 particular boys should be always together. So totally we have 6 boys. Okay. So out of them 2 boys are always together. So remaining is 4 boys. So I'll tie them as 1. So therefore 1 plus 4 is equal to 5. Okay. And also this, if A is 1 boy, B is 1 boy, either they can be seated in AB or in BA form. So therefore this is 2 factorial. Now let me count about the total factorial. So now, so here the number of ways. So number of ways so that 2 particular boys sit in the form of a circle is how much? 5 minus 1 factorial, which is 4 factorial. Okay, what about the boys inside the unit? So they will be considered separately as 2 factorial. Like they can be seated in the form A or B or B or A. So therefore my total ways. So total ways will be 4 factorial into 2 factorial. So this is how 6 boys can be arranged whenever 2 particular boys are always together. Next question. In how many ways 5 boys, 5 girls can be arranged in a circle if no 2 girls are together? So no 2 girls are together means they have to be between the boys. So let me arrange boys first. Okay. So the arrangement of boys, 5 boys, arrangement of boys. Okay. Arrangement of boys will be 5 minus 1 factorial, which is 4 factorial. Now here comes the question, what about for the arrangement of 5 girls? No 2 girls are together. Okay. In case of linear permutation, suppose you have boys like this, B1, B2, B3, B4, B5. You have to fill the girls in between the boys. Either you have to start from first or from last or in between them. Okay, so that no 2 girls are together. So you will be having 6 places for 5 girls. But what happens in case of circular permutation? So you have arranged boys. Okay, so girls you have to be arranged here. Here. How many places you have? You have exactly 5 places for 5 different girls. So there is no minus 1 here. Okay. But for boys, it is 5 minus 1 factorial. For girls, you have exactly 5 different places. So therefore, arrangement of girls between them will be exactly 5 factorial. Okay, do not make it confused. So arrangement of boys is 5 minus 1 factorial because it is in circular permutation. So therefore it must be in the form of n minus 1 factorial. Well, coming to the girls, you have exactly 5 places where 5 girls can be filled. So therefore it is 5 factorial. So therefore my total ways will be 4 factorial into 5 factorial or 5 factorial into 4 factorial. So whenever in the case of linear permutation, you would consider it as 6p5. 6p5. Out of 6 different places, you have to fill 5 different girls in between boys. So you would have considered it as 6p5. But in case of circular permutation, so the places remain same. So therefore it is 5 factorial. Okay. Next question. Find the number of ways in which 8 men be arranged around a table so that 2 particular men may not be next to each other. So we can count the permutation where 2 men can sit together. Okay, 2 men can be together. So what is the logic behind this question? Let us find out total ways. Okay, so if you subtract them by 2 men always together, okay, 2 men always together, then this gives number of ways 2 men not be together. This is the logic I have to use here. Okay, so how many men we have? 8 men. Okay, so let me consider total ways, then 2 men always together. When I subtract it, I'll get the answer for 2 men may not be together. Okay, first let me take my total ways. What happens for total ways of arranging 8 men? It is 8 minus 1 factorial, that is equal to 7 factorial. Next, 2 men always together. So we have 8 different men. Okay, so 2 men are together, 6 men are remaining. So consider them as 1 unit. 1 plus 6 will be 7. Okay, so therefore 2 men together. What is the arrangements for 2 men together? It is 7 minus 1 factorial, okay, which is 6 factorial. What is the arrangement of these 2 persons? Into 2 factorial. Why into 2 factorial? Because they can be seated in the form of AB or BA. Okay, so the total arrangement will be n minus 1 and the arrangement of 2 persons will be 2 factorial. Now I can subtract it directly. So therefore number of ways 2 men not be together can be written in the form of like this. So what is my total ways? It is 7 factorial. What is the total ways where 2 men can be together? That is 6 factorial into 2 factorial. So this is my answer for the given question. Next question. In how many ways can 6 gentlemen and 4 ladies be seated around a table so that no 2 ladies are together? Okay, so let me consider now 6 arrangement of 6 gentlemen in a circle. Okay, so G1, G2, G3, G4, G5, G6. Okay, now we are arranging 6 gentlemen. So gentlemen's arrangement of gentlemen's, okay, that will be 6 minus 1 factorial, that is equal to 5 factorial. Okay, what about the ladies? What is the condition? No 2 ladies are together. We cannot put 2 ladies together, so they have to fill in between these gaps. How many gaps we have? 6 gaps. Okay, so we have 6 gaps. How many ladies are there? 4 ladies. So therefore for ladies, the arrangement will be 6P4. Why 6p4? Because we have 6 different places, only 4 ladies. So we have to fill the 4 ladies in between the gentlemen's. Any 4 places you can choose. So therefore it is 6p4. So therefore my total ways here is 5 factorial into 6p4. Understood? Next question. Find the number of ways in which 15 staff members can be seated around a circular table for a meeting if the vice principal and dean have to be seated on either side of the principal. Okay, so we have to arrange them in a circular way. But vice principal and dean must be always on the either side of the principal. That means the place of principal is fixed. Only vice principal and dean can change their places, but only on the either side of the principal. Okay, so now let me arrange them. So we have 15 staff members, right? So we have 15 staff members. So vice principal, principal and dean, they have to be separated, okay, and should be considered it as one unit. And remaining 12, we have 12 staff members. So how many now? 1 plus 12 is equal to 13 staff members we should consider. Now what will be the number of ways for 13 staff members? So therefore number of ways will be 13 minus 1 factorial, which is 12 factorial. But what about the unit inside here? Principal cannot change his place, okay, because he has to be in between dean or principal. Only thing is vice principal or dean can change their places. That means only 2 people can change here. So therefore for this unit, number of ways will be only 2 factorial. So number of ways of vice principal, principal and dean is only 2 factorial. Okay, don't confuse it with 3 factorial, because in my previous example, red, yellow, green, all are different. Okay, all can change their places. So therefore we assumed it as 3 factorial. But here principal has to be in the middle of vice principal and dean. So the place of principal is fixed. So we cannot take him as count. So only vice principal and dean can change their places. So therefore it is 2 factorial. So therefore my total number of ways for this circular permutation will be 12 factorial into 2 factorial. So I hope you all enjoyed today's class and you have learned something about circular permutation. So to be clear, it is very different from linear permutation. So whenever you have n objects for linear permutation, it is n factorial. When it comes to circular, it will be n minus 1 factorial. But remember, for necklace and garland, it will be n minus 1 factorial by 2. So we'll meet you in the next session. So until then, keep watching, keep learning, keep exploring. Thank you.